Hello, can you hear me?
Yes, yes. Can you hear me?
Yeah,
Oh,
okay. We'll cover some of the algebra theory.
okay,
So the first topic is sequence and series.
okay.
So do you know what is an arithmetic sequence and a geometric sequence?
Yes.
Arithmetic sequence is something like this.
Yeah, yeah.
What is the sum of an arithmetic sequence to n terms?
It's n by 2 into 2a plus n minus 1d.
Right. Geometric sequence is like this. It has a common ratio.
Yeah.
The sum of the n terms of geometric sequence is
A into Rn minus 1 over R minus.
like this.
Yes.
And obviously, if mod of r is less than 1, then
Top the order. 1 minus R power.
this infinite series is also having a finite sum.
Yeah, it's A by 1 minus R.
If mod of r is greater than 1, then it is not going to have a finite sum.
Yeah.
Only if mod of r is less than 1, then it has a finite sum and it will be a by 1 minus r.
Yes.
Have you heard of an arithmetic geometric progression AGP?
Uh, I think so, yeah.
How do you sum that? It looks like this.
This one, like you're supposed to take, like multiply by R again and then subtract off, I think, something like that.
Right. So the general method is you write out the series like this. This is what we need to add, let's say, to n terms. So it will be a plus n minus 1 d r power n minus 1.
Yeah.
Then you multiply by the common ratio and you shift the terms one step to this side. So if you multiply every term by r, it will be ar here, but don't write it here, write it here.
Okay.
Then this will become a plus d r square, right?
Yes.
So the benefit of shifting it is now subtraction will make it simpler. This would become a plus n minus 2d r power n minus 1. And the last term will not have a counterpart above. It will be a plus n minus 1d multiplied by r power n, right? Correct? If you subtract right now, you will get s into 1 minus r here. You will get a here because nothing to subtract from.
Yes.
And you will get from here, you will get a dr, from here you will get a dr square, and so on.
Yes.
Till here, you would get a dr power n minus 1.
Yes.
And the last term here will come with a negative sign, a plus n minus 1 d r power n. This series is a GP
Yes.
whose sum you can write, and then you divide by 1 minus r to get the s that you need.
Yes.
So that is the general method. You don't have to remember the formula. You need to know the general process.
Okay.
So that is your AGP. Then uh, let's look at sequences. The theory is just this much. After
Okay.
that, you need to know like how to apply it in different contexts. So we'll discuss some problems slightly later. But before that, we'll look at a little bit of polynomials and theory of equations.
For sequences, we don't need to know like double summation and all that. It's not.
You don't need, there is no theory for it. You need to know how to solve problems in case it comes.
Okay.
There is no theory that you need to know there. You just need to be able to handle the summation.
Okay.
So that will come when you do some problems. But otherwise, the only theory there is that is telescoping series. If there is a sum of a series you need, you should be able to split a term into a difference of two terms
Yes.
and then add it up in such a way that things start canceling off. But that again is a problem or is a problem-based thing. So when we do some problems, we'll get the hint of what to do there. The next major topic is polynomials and theory of equations. So here, first of all, you need to know what a polynomial is. Polynomial is a function that looks like this. Something like this. This is a polynomial. Here, the powers of x powers have to be positive integers.
Okay.
Positive integers. The highest power is known as degree of the polynomial.
Yes.
Highest power, in this case, it is n, is the degree of the polynomial. And after that, the terms an minus 1, a1 to 0, an minus 1 till a1 and a0 are constants and could be any type of number, could be complex numbers, could be real numbers, could be rational, irrational, and so on.
Okay.
Could be integers. So those are called the coefficients of the terms.
Yeah.
And the special, this term, this coefficient, the first coefficient is known as the leading coefficient.
Okay.
So leading coefficient of the polynomial is the coefficient of the highest degree term. In this case, it is an, right? Now you need to know something called polynomial division. Basically, you have learned it in lower classes, I'm guessing, how to
Yes.
divide two polynomials.
Yeah.
The main thing to remember is just like in numbers, when you do division, it is like this in numbers, right?
Yes.
Here we are dividing A by B and we are getting quotient Q and remainder R, right?
Yes.
The property of the remainder is that the remainder should always be less than B and could be 0.
Yes.
Because B is what we divided it by, right?
Yeah.
So if remainder was greater than B, that means you should have taken one more Q plus 1, right, as a quotient. Do you understand what I'm saying? You should not have a remainder bigger than B because that means you didn't choose the right quotient, right?
I got it.
Okay. So this is normal number division. Polynomial division will follow the similar principle. You say px by px by, let's say qx, not qx. Let's say we are doing dividing ax by bx, right? These
Okay.
are two polynomials. So we can write ax is equal to bx times qx plus some rx, right?
Okay. Yeah.
This is your quotient polynomial,
Yes.
and this is the remainder polynomial.
Okay.
Now, what you need to remember is obviously the degree of the remainder could be from 0, but has to be less than the degree of the quotient.
Okay.
Do you understand what I mean?
Yes. Yes. I get it.
If you are dividing, say, x power 4 minus x squared by something like x squared plus 1, this is my term that I'm dividing it by. Degree of quotient is a mistake. It should be less than the degree of the divisor.
Yes.
Divisor is the B polynomial, right?
Yes.
So if I'm dividing by x squared plus 1, I can do whatever. I'll get some quotient and all, x square first time. You'll get x power 4 plus x square. Then when I subtract, I will get a minus 2x square here, right? Then I will do a minus 2, right? So I'll get a minus 2x square minus 2. When I subtract, I get a plus 2, right? Now there is no way to divide this by this
Yeah.
because this is already degree 0.
Yes.
It's a constant, so it's a constant polynomial, right?
Yes.
So this becomes our remainder, this becomes our quotient, this is our divisor, right?
Yes.
So reminder's degree cannot be equal to the quotient's divisor's degree because Here it was already equal to the divisor's degree. We are able to do one more step after that, right?
Yeah. Yeah.
So that is your polynomial division. This is very important to know. Just like numbers, you have to think of it like that, right?
Okay.
And you should be able to write a relationship like this.
Okay.
From here only, we will get something like remainder and factor theorem. Remainder and factor theorem, which is very useful. So
Okay.
basically, we say that if Px is a polynomial, is divided by something like x minus a, right? This is my divisor polynomial, right?
Yes.
So notice that the degree of the divisor is 1. So the quotient will always be constant, right? Degree 0, remainder will always be degree 0, right? Why?
Yeah.
Because the divisor has degree 1. It's a linear thing I'm dividing it with, right? So remainder cannot be linear. It has to be less than the degree of the divisor, right?
Yes.
So this time the remainder will be a constant. So we can say Px is equal to some Qx quotient times x minus a plus remainder. You can write it as Rx, but this turns out to be a constant or
Yes.
degree 0, right? Correct?
Yes.
If I wanted to find the remainder directly without actually having to divide, what I should do here is put x is equal to a in this equation.
Okay.
You will get P of A is equal to Q of A minus A, which becomes 0, plus R of A, right?
Yes.
So technically this is 0. So we are getting R, which is actually a constant, is equal to P of A.
Yes.
So this is what is called remainder theorem.
Okay.
That when you divide a polynomial by a factor like x minus A, the remainder is put A in the polynomial, P of A.
Okay.
Do you know this? Have you seen this before?
Yes. I've seen it.
Okay, so that is remainder theorem, and very closely related to that is factor theorem. So if the remainder is 0, right, which means P of A is 0, right, then we say that x minus A is a factor of P of x.
Yes.
When something is a factor of P of x, the remainder should be 0 when you do division, right?
Instead of P of X, right? We wrote R of.
Right, P of x, obviously.
Yeah.
P of x is divided by x minus a. X minus a will be a factor if the remainder is 0, and remainder is 0 means P of a is 0.
Okay. Got it.
So that is a good way to check whether something is a factor of a polynomial or not.
Okay.
Okay. Then when you think of solving equations and all, usually we need to know one thing called Vieta's theorem. Okay.
Yes.
But before that, the fundamental theorem of algebra also you need to know. Fundamental theorem of algebra says if you have a px equals 0 equation,
Okay.
here px has degree n, then this equation always has n roots.
Yes.
Always has n roots. The n roots could be real or complex numbers. We don't know.
Yeah.
We don't know the nature of the roots yet, but we know that it has to have n roots.
Okay.
Some of the roots could be repeated.
Yes.
For example, there are many quadratics where you'll quadratic like this.
One. Yeah.
The roots are both 1 and 1.
Yes.
So there are two roots which are both equal to 1, basically.
Okay.
So you have to count when you say n roots, you're not saying that there is only one root here. You're saying there are two roots, both are equal to 1. So when we count n roots, we are counting them with their multiplicity.
Okay.
Do you understand what I'm saying?
Yes. Yes.
That is the fundamental theorem of algebra. The proof is very advanced. We can't do the proof.
Okay.
After that, our job is to, okay, let's try to figure out the roots. There, we have discovered something called Vieta's theorem, which is very useful. So if you have a polynomial like this, this is my polynomial which is equal to 0. A1x plus A0 is 0. Then technically we are supposed to have n roots here. Alpha 1, alpha 2, alpha 3 up to alpha n are the roots,
Yes.
right? So Vieta's theorem says that we can figure out what is the sum of the roots. So in general, it says sum of the roots taken one at a time. So this part is important to understand, taken one at a time. So if you pick the roots only one at a time and try to add them, it will simply be the sum of the roots, right?
Yes.
So sum of all of these roots will be, and the pattern was also important to remember. You always start with a negative sign, -1 times the second coefficient by the first coefficient.
Okay.
It is always the coefficients here, you have to divide them by the leading coefficient. And the pattern is that it is negative, positive like that. So this was sum of the roots taken one at a time. It was simply the sum of the roots and it will be always equal to this. Then if I had to do sum of roots taken two at a time, So what does that mean?
There's like alpha 1, alpha 2 plus alpha 3.
So you have to select out of these n, if you select two of them, the number of ways to do that will be nc2, right? N choose two, these are the number of ways of selecting just two out of these n, right?
Yes.
So nc2 ways will be there and you will take all such combinations, alpha 1, alpha 2 plus alpha 1, alpha 3 plus alpha 1, alpha 4 till alpha 1, alpha n. Then you will start alpha 2, alpha 3, alpha 2, alpha 4, right?
Yes.
Till alpha 2, alpha n, and you keep going like this till alpha n minus 1, alpha n.
Okay.
This will be the sum of the roots taken two at a time. It will always be equal to, now there was a minus sign with the first, now you do a plus 1, and now it is the second term here after this, right? An minus 2 by an.
Okay.
So the pattern is you start off with this coefficient by this, then this coefficient by this, then this coefficient by this, and so on.
Okay.
And you keep alternating the signs, -1, +1, -1, like that.
Yes. Okay.
Similarly, you'll take sum of roots taken three at a time, would be things like this, alpha 1, alpha 2, alpha 3, plus alpha 1, alpha 2, alpha 4, and all such three pairs, right?
Yeah.
That would be minus an minus 3 by an.
Okay. Got it.
So this is the general result true for any equation. Now, if you apply it to, for example, quadratic and cubic equations that you are most likely to see, we will get the familiar results. Let's say these are our quadratics and cubics. So here quadratic will have only two roots, right?
Yes.
So sum of roots taken one at a time would be minus b over a.
Yes.
And if you take them two at a time, there is only one pair possible, right?
Yes.
So that will just be product of the roots actually.
Okay.
There is no other option for two at a time, right?
Yes, that is.
So now minus and then plus c over a, right?
Yes.
Similarly here, sum of the root, now there are three roots, alpha, beta, gamma. If you want to take sum of the roots taken one at a time, we will start off with a minus sign and minus b over a. Then if you want to take two at a time, you will say alpha beta plus beta gamma plus gamma alpha is equal to, you should say plus now, c over a, right? And finally, three at a time, there is only one pair, triple, right? There is no other option. There is only one term here, three at a time when you do, right?
Minus.
And that will be minus d over a. Do you understand?
Yes.
So that is very important to know. Now, for a quadratic equation, we do a little more analysis because this is very frequent. For
Okay.
cubics Also, we'll discuss some points, but quadratic equations are more common, so we'll discuss how we solve them.
Okay.
So the way of solving it is taking a common, you'll get x squared plus b by ax plus c by a equals 0. Obviously, a cannot be 0 because otherwise then equation only will not be quadratic.
Yeah.
So if a cannot be 0, we can cancel it out and our equation becomes simply this. And notice first of all that we have just now gotten by Vieta's relation alpha plus beta is minus b over a and alpha beta is c over a.
Yeah.
So this thing which is equivalent to our original equation can be written as x squared minus alpha plus beta x plus alpha beta,
Okay.
right?
Yes.
Which is easily factorizable, x minus alpha, x minus beta.
Yes.
So basically our quadratic equation can be written as a times x minus alpha, x minus beta equals 0.
Yes.
Obviously that's how the roots have come because these factors are available, right?
Okay.
So this is something that you need to know. If the roots were given to you, you can form the quadratic equation like this.
Okay.
If the roots were known to you, then you can do x square minus sum of the roots into x plus product of the roots equals 0 will be the relevant quadratic equation for those roots.
Okay.
Do you understand what I'm saying?
Yes.
Okay. If you want to solve it, it is solved by the completing the square method. You multiply this term by 2 and divide by 2 also. And then you add b by 2a whole square to it and subtract b by 2a whole square from it plus c by a equals 0. This part, the first three terms become x plus b by 2a whole square.
Yes.
And that can be taken on the other side. It becomes b squared by 4a square minus c by a. And finally, if you solve this now, x will come out to be minus b by 2a plus minus root over b square minus 4ac divided by 2a.
Okay.
This is your quadratic formula. So the roots are alpha is equal to minus b plus root over b square minus 4ac by 2a and beta is minus b minus root over b square minus 4ac by 2a. Right? These are the two roots which came, plus sign and a minus sign. Do
Got
you
it.
understand these things?
Yes, I got it.
Okay. Here, the nature of the roots can be figured out by the nature of this term, which is known as the discriminant of the quadratic.
Yes.
So, if the roots of my quadratic are minus b plus minus root over b square minus 4ac by 2a, this quadratic for us was ax square plus bx plus c equals 0. Obviously, if b square minus 4ac is less than 0, then the roots will not be real.
No real roots.
So this will be the condition for complex roots or no real roots, right?
Yes.
If b square minus 4ac is equal to 0, then both the roots will be actually minus b by 2a and minus b by 2a.
Okay.
Real and equal roots.
Yes.
Because the root part is disappearing, so both the roots will be the same, plus minus 0, right? And if third case is v square minus 4ac is greater than 0, then we will get two unequal and real roots.
Yes.
Correct?
Yes.
So this is very important to know. The nature of the roots is decided by the value of this discriminant. B square minus 4ac is called the discriminant of the quadratic.
Yeah.
And the graphs of the quadratic also you should be aware of.
Yes.
These are the three versions of the graphs. If a is positive, if a is greater than 0, ax square plus bx plus c, the function is a parabola that opens upwards.
Yeah. Yeah.
And this graph is the graph where it is cutting the x-axis at two different points. So this is two real
Roots.
and unequal roots.
Yes.
This is your alpha, this is your beta. So obviously, for this to happen, you have to have discriminant greater than 0.
Yes.
For this to happen, a greater than 0 and d equal to 0,
Yes.
because both the roots are equal.
Yeah.
For this to happen, there are no real roots, so this is the condition.
Yes. Got it.
And similarly, there are 3 versions of the graph if it opens downward.
Yeah.
This is d greater than 0, but a less than 0. This is d less than 0, a less than 0. This is d equal to 0, a less than 0.
Yeah. Got it.
So these graphs and all you should be aware of, because again, sometimes it is important. And also the point where this is the symmetry of the parabola. So this point is known as the vertex.
Yeah.
The vertex of the parabola always happens at x is equal to minus b by 2a.
Yes.
The parabola curve is symmetrical about the vertex. Whatever is on this side, there is on this side. Reflection.
Yeah.
So this is your vertex of the parabola. You can always find the minima or maxima of the parabola depending on whether it opens up or it opens down.
Okay.
That minima and maxima will be at the vertex,
Okay.
right? Okay, then let's look at some problems now. Because theory-wise, equations and all, you need to know only this much. Do you know logarithms?
Yes. Yes. I know.
Okay, fine. Uh,
Mostly it's like inequalities and functional equations that like I know like basic inequalities, but then yeah, not the advanced ones.
you don't need to know any advanced ones for this level.
Okay. Okay.
You need to do enough problems. That's the missing thing. You need to know like some algebraic identities, first of all. Algebraic identities,
Yeah.
like what is a square minus b square?
A minus b, a plus b.
You obviously know this, right?
Yes. Yes.
This is the formula for this. Then
Yeah.
what is a plus b whole cube?
I usually expand it out, but
That's not the way to do it. That's going to take a lot of time, right?
a cube plus b cube plus 3a square b plus 3.
Not like that. You can't remember it like that. You have to remember it like this. This is the formula. You need to remember this identity.
Okay.
Don't expand it out. That's for people who have never done algebra.
Oh,
These two have to be remembered. This is how you do it. Okay. Do you know a cube plus b cube? Factorization.
no.
So these are missing things, which that's why you're struggling.
Okay.
This is a standard factorization. Everybody has to be aware of it.
Okay. What is a minus b a square plus ab plus b square?
These are standard. Now, the generalization of this is, okay, before that, there is another identity that is super important. A cube plus b cube plus c cube minus 3abc. What is the factorization of this?
Not too sure.
A plus b plus c multiplied by a square plus b square plus c square minus ab minus bc minus ca.
Okay.
Again, write down these in your notebook. These have to be remembered. There's no option here.
Okay.
Have you written down all of them?
Yeah, I'll write it down like after the class. I've taken a screenshot.
Okay. This identity is important because sometimes you have a situation where if a plus b plus c is 0, in that case, you can say that the right-hand side is vanishing, right? Then you can say a cube plus b cube plus c cube minus 3abc is 0, right?
Yeah.
So in that case, you have a cube plus b cube plus c cube is equal to 3abc.
Yeah. Yeah.
So this is a special condition. Many times it is used in problems. If a plus b plus c is 0.
Okay.
It comes from here. You need to know this identity. From here, it is obvious why this is working.
Yeah. Yeah.
Also, you need to know that this quantity inside is always positive.
Okay.
Why?
Uh, A square, B square, and C square are always positive. Then
You're not
not.
talking about just those three. We're talking about the whole bracket.
Uh,
This quantity
one.
is always greater than equal to 0. Why? The reason is that you can do this half into 2, right?
Okay.
And why did we do a 2? Because now I can split these and make perfect squares.
Oh, okay.
I will use 1 and a square, 1b square here. Then I'll use 1b square, 1c square, and 2bc. And then I'll use 1c square, 1a square, and 2ca, right?
Yes.
If you
Okay.
see, all of them are now twice.
Yes.
And this is clearly a minus b whole square plus b minus c whole square plus c minus a whole square. And the whole thing divided by half.
Yeah.
Sum of squares is always going to be greater than equal to 0,
Yes.
right? So that's why it is positive.
Okay. Got it.
Do you understand what I'm saying?
Yes.
Okay. Then we have a couple of standard identities, slightly more general. A power n minus b power n can always be factorized like this. This is always true.
Okay.
The reason is because if this is my expression, I can prove that a minus b is always a factor of this expression.
Okay. And then you can like divide it.
Because if you put a is equal to b, this will vanish, right?
Yes.
Think
Yes.
of it like an x power n minus b power n. You can always show that x minus b is a factor, right?
Yes.
Because x is equal to b makes this vanish by factor theorem,
Yes.
right?
Yes. Yes.
So now I just replace x with a, you will say that a power n minus b power n, a minus b is a factor.
Yes.
And upon dividing, you will get this. This
Yes.
is useful because it is a general case.
Okay.
It will give you the result even if you do a power 5 minus b power 5
Okay.
is equal to a minus b. And notice the pattern that is happening inside. The inside thing is one less degree than this, right? You start off with the a power, but with a 4 instead of a 5, right?
Yes.
Then every term, notice, has the same degree, n minus 2 plus 1, n minus 3 plus 2, right?
Yes.
So it will be a cube b plus a square b square plus a b cube plus b power 4.
Yes.
So you need to know this formula and understand the pattern so that you can also write it if necessary,
Okay.
right?
Yes.
Then there is Sophie Germain. Have you heard of this?
No.
A power 4 plus 4 times b power 4. I want to factorize this.
Okay.
Obviously, there is no easy way to directly factorize it. We need to do some change to it in order to be able to factorize this, right?
Yes.
Factorizing means writing it as a product of two things, right?
Yeah. Yes.
So how can we make a change to it? So what we'll do is a power 4 plus 4 power 4 b power 4. We will add 4a square b square to it and subtract 4a square b square.
Okay.
Why did we add this?
We can like make it into a perfect square.
Right. This is now a square square plus 2b square square plus 2 times a square into 2b square, right?
Yes.
Minus 4a square b square, which doesn't change anything, but it has made this perfect square.
Yes.
So this is a square plus 2b square whole square minus, think of this as 2ab whole square.
Yeah.
And now I'll use my a square minus b square identity.
Yes.
I will say this is equal to a square plus 2ab plus 2b square multiplied by a square minus 2ab plus 2b square.
Yes.
So basically, I have gotten a factorization for this now.
Okay.
Do you understand?
Yes.
Okay, so that is a very common trick sometimes in problems. Then there is also something called Simon's favorite factoring trick,
Okay.
SF favorite fact SFFT.
Okay.
So this basically says whenever you have a situation like this, suppose xy plus 3x, xy plus 3y plus 4x is equal to 18. If you have an equation that looks like this, what we
Okay.
can do in such situations is think of this here, x plus 3 common y, right?
Yes.
But we have a plus 4x equals 18. We don't have the relevant things to take it common now, right?
Yeah. So you can.
It would have been nice if we had a plus 12 here, right?
Yes. So you can bring from the 18 over.
You can bring it from there or simply add a plus 12 and subtract a plus 12 and bring it to that side 30, right?
Yeah.
So then you will say 4x plus 3 and you'll get x plus 3y here and you'll take x plus 3 common and we'll say x plus 3 into y plus 4 is equal to 30.
Yeah.
This type of an equation is much more easy to handle than this type of an equation.
Yes.
Why? Because here it's a product of two numbers, and if the problem had said that it was integers or something, I know immediately what are the possible integers now.
Okay.
It can either be 215, 130, 5, 6, right? 10, 3. There are not too many options, right?
Yes.
So you can easily find x and y with by checking all of these options, but it was not obvious that these would be coming if I had just written it like this.
Yes. Okay.
So whenever you have some product term with two linear terms, right, then this trick might work. So you should take one factor and try to construct by force the factor and the other side also.
Okay.
X plus 3 had come here. We were forcing x plus 3 to appear here again, right?
Yes. Yeah.
We added a 12 to make that happen.
Yes.
So that is a common trick in problems. You should be aware of that.
Okay.
Okay, now 1 second. Let me see what else is there. System of equations. Okay, inequalities is there, but inequalities will not cover today. Today, we will just focus on what we have learned and do some problems. And maybe tomorrow or day after tomorrow, I will do inequalities, whatever is required at this level.
Okay.
So
Which ones
let's,
are required?
huh?
Which inequalities are required?
AMGM and Cauchy shorts, that's it.
Okay.
Nothing else is required.
Okay.
If you know these two and can apply these two, that is more than enough.
Okay. Yeah, I know both of them, but like I'm confused when to apply which one. That's the.
AMGM, HM, you should know all three.
Oh,
But we will discuss inequalities separately. Right now, don't worry about them. Focus on making sure that any sequence problem, any equations problem, polynomials problem, you are able to handle,
okay.
right? Inequalities we'll anyway discuss. So let's start out with some problems.
Okay.
You are studying functional equations also,
I think it's like tested in the Olympiads, so, but I haven't done it much.
but at this level, I doubt if any functional equations question will come.
There were like 2, 3 questions, I think.
Okay. Okay, if there are functional equations questions, then we'll discuss it in the next week and all. But functional equations is a much harder topic. So it's not like some easy thing that can easily be done.
Okay.
Usually, if you know the standard basic level functional equations, then you should be able to handle the first round questions by basic stuff.
Okay.
But it's a long thing, it's a big topic. Okay. So
Yeah.
don't worry about that right now. Let's look at some problems for now. So first question is, for each positive integer k, for each positive integer k,
Yes.
let Sk denote the increasing arithmetic sequence of integers, arithmetic sequence of integers whose first term is 1 and common difference is k. Okay.
Okay.
For how many values of k? For how many values of k does Sk contain the term 2005? Contain the term 2005. So Sk denotes an increasing sequence whose
Yes.
first term is 1 and common difference is k, right?
Yes.
So what is a random term or Tn term in the sequence Sk?
1 plus n minus 1 into k. 1 plus n minus 1 equals
1 plus, no, not n minus 1. N minus 1 into k, correct. So this is the Tn terms here, right?
Yes.
Correct. So if this is the Tn term, what we need to ensure is 2005 a part of it, right?
Yes.
Correct.
Yes.
So we want to count how many k's are there such that 2005 is a part of it where n is an integer, right?
Yes.
And k is also an integer, right?
Yes.
So this is my equation, no?
Yes.
So 2004 is equal to n minus 1 into k, correct? And now we need to count how many such k's are possible,
Okay.
right?
Yes.
So now this is a simple problem. Just take the factorization of 2004, right?
Yes.
So if you do the prime factorization of 2004, it is 2 into 1002. So
2 into 2 and
again 2. So 501, right? Right?
yes.
501 into 4 basically, and 501 can be divided by 3. So 3 into, it will be 167, right?
Okay.
Correct?
Yes.
So basically it is 2 square into 3 into 167.
Yes.
That is equal to n minus 1 into k. And what we have to do is figure out how many such k's are possible, right?
Yes.
So tell me, try to think about it.
So we can do like k can be 2 into 167, 2 into 3, 2 into 2 like that. That we can take it.
Basically, k can be any factor of 2004, right?
Yes. Yes.
So you just need to know how to count the factors of a number. Count
Yeah.
the number of factors, right?
Yes.
So do you know method to count the factor? We know the prime factorization. How many factors are there?
Not like too sure. I just manually do it.
Manually, you can't do it. You need to know the method. So anytime you have a prime factorization, how many divisors, how many factors will be there, right? That includes 1 and that includes 2004 also, by the way.
Yes.
Those are also called factors, right? So the way to do it is look at the power of each prime factor. So
Okay.
you will say 2 is power is 2, right?
Yes.
But when you make a factor, let's say we are constructing a factor.
Would you add all the powers?
No.
Okay.
When you're constructing a factor, you have 3 types of prime numbers, 2, 3, and 167.
Yes.
What power would you assign to 2?
2.
Why? How do you know it will be 2? It could be 0 also, 1 also.
Okay.
Do you understand what I'm saying?
Okay. Yeah.
You don't understand. This is my number n. I want to find out how many factors are possible, right?
Or you can assign 0, 1, or 2 to 2.
Yes,
0 or 1 to 3.
yes.
0, 1
So
to.
when I construct a factor, these are my spots for the prime numbers, right? I don't know what power I will keep, but I can keep anything, 0, 1, or 2, right? Right? For this 3, I can keep 0 and 1, and for this, I can keep 0 and 1, right?
Yes.
So the number of choices here are 3, the number of choices here are 2, the number of choices here are 2, right?
Yes.
So the number of possible factors will be choices, you have to multiply the number of possible choices.
Okay.
It will be 12 factors here because you are doing 3 into 2 into 2.
Yes.
Anytime you have a number, if you know the prime factorization is 2 power A, 3 power B, 5 power C, the number of divisors would be number of choices for A are 0 to A, right?
A plus 1 into B plus 1 into C.
So A plus 1 into B plus 1 into C plus 1 is the number of divisors or factors of this number.
Yes.
So in this case, there are 12 factors of 2004 and K could have been any one of them, right?
Yes.
This was my equation.
But n minus 1 cannot be 0, right? So K
No,
cannot be 2.
that's fine. K can be anything. K can be 1 also. Why? Who is saying that 0 has to be there?
Because if n is 1 and k is 2, wait.
It's not n. We are talking about n minus 1. N minus 1 can be 1. No.
Oh, yeah, yeah. Okay.
You understand?
I got confused.
K can be anything from 1 to 2004, right? All the 12 factors.
Yeah, yeah.
For each case, you will get some integer n.
Yes. Okay.
So the answer will become 12 here. 12 such Ks, right?
Yes.
So again, the problem started off looking like a sequence question, but sequence part was just getting the formula. After that, it was a counting problem.
Yes.
That's what happens usually. Problems will be mixed and use different topics also,
Okay.
right?
Yes.
Second problem is this one. Px is equal to x cube plus x square minus r square x minus 2020. Px is a polynomial. Px is a polynomial with roots r, s, and t.
Okay.
With roots r, s, and t. You have to find the value of p of 1.
Okay.
Try it out.
Okay.
Use Vieta's relations.
That's it.
So tell me what equations you get by Vieta's relations.
You get r plus s plus t equals to minus 1.
Hmm.
Get r s plus st plus tr equals to minus r square. and you
Mhm.
RST equals to minus 2020.
No, RST, I think you're making a mistake. You have to keep the signs alternating, no?
T20.
If you make a mistake like this, it will not work out, right? These are the three equations you have, right? And what do you need to find? We need to find P of 1. So let's calculate P of 1 by putting 1 here, right?
Minus R square minus 28.
So this is minus R squared minus 2018,
Yes.
right?
Yes.
So somehow we have to figure out this value
Yes.
using this much information, right?
So we need the value for R square.
Uh, we need the value of R squared, and for that we need to somehow try to eliminate our S and T, right? Like S and T is the annoying stuff, no? Do you understand what I'm saying? Now try it out, see what you can do. Look at the second equation, okay?
Yes.
You can bring the R square to this side, right? R square plus RS plus ST plus TR is 0,
Okay.
right?
Yes.
Now here, there are many terms which have an R here. So maybe we should do that. We can take R common in these three terms, right?
Wait, I did R equals to 20, ST equals to 2020 by R, and then I subbed it in the second equation.
But that is not a good strategy because then you are removing R only.
No, like, but then I can sub it in the second equation to remove the ST over there. And then,
Okay, that may work. But okay, that is possible because then you can take R common and do S plus T, right?
yeah.
From the first one. So that is also possible. You can try it out and see if it works out. But see what I am trying to do here. I am saying R S comma T plus ST is 0, right?
Yes.
And I know already R plus S plus T is minus 1, right? Correct?
It's minus R plus ST is 0.
So from here I am getting ST is equal to R, right?
Yes.
So then I'll put it in third one and say R square is equal to 2020,
Oh, okay.
right? So I'll get the answer very easily now.
Yeah.
So although what you are trying is also doable, there is no issue with that. It's just slightly longer. Do you understand? We are taking advantage of R plus S plus T here, right? To directly eliminate so many things and get ST directly, right? Do you understand?
Got it.
But it's ultimately about Vieta's relations. Can you write them correctly and can you use them?
Oh,
What you are doing is also fine because ST is 2020 by R. And then you can take here RS and TR are common, S plus T. And S plus T can be written as minus 1 minus R,
yes.
right? And plus ST is 2020 by R is equal to minus R square. Minus R square will get cancelled.
Yes. Yes.
And you will get an equation with one R in the top and one in the denominator, which will help you get R square.
Yeah. R square is 20.
So doable question, just need to know Vieta's relation. Okay. Is it clear?
Yes.
Okay. Next one is two distinct real infinite geometric series. Real infinite geometric series have a sum of 1. Each have a sum of 1. Each have a sum of 1 and have the same second term. And have the same second term.
Okay.
Okay.
Yes.
The third term of one of the series is 1 by 8. Third term of one series is 1 by 8.
Okay.
And second term and the second term of both series can be written as root over m minus n by p, where m, n, and p are positive integers. M and p positive integers. And they have also said m is not divisible. M is not divisible by the square of any prime.
Okay.
The reason they are saying that is because if it was divisible by the square of a prime, then maybe
Okay.
you could have a common factor or something, right? You have to find out 100m plus 10n plus p.
Okay.
Okay, try it out.
Okay.
What are you trying?
I just wrote down the relations. Now I'm trying to like compare them. I think I kind of got it.
Don't try to make too many variables. What you should say is they have the same second term. Let's call that second term x.
Okay.
Don't try to make multiple variables. There is a temptation to do it like a, ar, and so on, right? There is a temptation to keep writing it like this b, bs, and bs square, and so on like that, right? Two separate series. Don't do that because then there are so many unknowns, right? Do you understand what I'm saying right now?
So, okay, wait, I think I got the answer. Give me like a minute.
Okay.
Okay, wait, I'm not getting.
See, what I'm saying is this. I'm going to take only one variable x, which is the second term, which is common to both series, right? Third term of one series is 1 by 8. So third term is 1 by 8, second term is x. What is the common ratio?
Right.
If we know common ratio is 1 by 8x and second term is x, what should be first term?
Divide by 1/8.
So first term should be this, right?
Yes,
Now sum of this series is going to be a by 1 minus r.
that's 1.
So we'll just put 8x squared by 1 minus 1 by 8x is 1, right?
Yes.
So getting 8x squared is equal to 1 minus 1 by 8x. To multiply by 8, so 64x cube is equal to 8x minus 1. So we are getting 64x cube minus 8x plus 1 is 0,
Wait.
right? Correct?
Yes. Okay.
It is a cubic equation, but you can guess a root here. It is easy to guess one root of this.
Oh,
Usually cubic equations, unless you guess a root, you cannot do it.
okay. We can.
Why? Because there is no standard formula for cubics, right?
Yeah.
So can you guess a root? Look at the equation and guess a root here.
Wait, I -2. Wait.
Won't work because 64 will make it too big, no? When I say guess a root, check the calculations whether the root is making sense or not, right? It is obvious that x is equal to 1 by 4 is a root. Check what happens if you put x is equal to 1 by 4.
Oh, it becomes, wait, 1 by 64. That minus. So 1 minus 2 plus 1. Yeah.
This is not a difficult thing to guess, by the way, okay?
How did you like get 1 by 4?
Because I know 64 is 4 cube, how to cancel that?
Oh, okay.
If there is a cubic term, what should I do to try to make it small or something?
You
I
tried.
need to like make it small by trying say 1 by 2, 1 by 4, something like that. 1 by 2 was not working,
Oh, okay.
right? You have to guess a root here. If I know x is equal to 1 by 4 is a root, obviously x minus 1 by 4 is a factor, right?
Yes.
So now you just need to divide this thing by x minus 1 by 4 to get the quadratic,
Oh, okay.
correct? X minus 1 by 4 will be a factor and you will get a quadratic here. It should be equal to 64x cube minus 8x plus 1, right? Correct?
Got it.
Find the quadratic, solve the quadratic, and then the quadratic's root should be in this form because the question has said that the second term can be written in this form. 1 by 4 is not a valid second term.
Yeah.
So it's going to come from the roots of this quadratic, which will give us other values of x, right?
Yeah.
Because we know that this thing is equal to 0. So if we can rewrite this like this, then we can solve the quadratic and say 0, you'll get a root terms.
Okay. Yeah.
But remember, what we did here was trying to avoid so many variables. We just took the common second term as x and figured out from there what will be the GP common ratio and terms and sum, right?
Yes. Okay. So we didn't use the second series at all, basically.
It was not required, right?
Ah.
Nothing was required about the second series. You needed only the series which had 1 by 8 because that is required to find that second term, right?
Oh,
Correct.
yes, correct.
You need to keep practicing your SMO paper algebra sections and also AMC 10 and AMC 12, whatever algebra problems you can find. We will do tomorrow, we'll discuss a little bit of inequalities and we'll also continue with our problem discussion. But ultimately, like improvement here will come by problem solving, okay?
Okay. Okay.
Concepts wise, there might be some things that I can add, or some points that you might not know, like the factorizations that we discussed, right? Those, make sure that you fix those, remember those, right?
Okay.
But ultimately, it's about practice, and you will see with a little more problems and all, you will start improving. Okay.
Okay. Okay.
But keep solving more and more questions and target the equations, polynomials, the sequence and series questions. We have covered that theory. Tomorrow we'll do inequalities, whatever is required.
Okay. Sure.
And Sunday and after that in the coming week, it will be all about more and more problems till
Okay.
you feel a little confident. Okay.
Okay. Okay.
Okay, fine. That's all for now then.
Okay. Thank you so much.
Bye.